Okay, just a little video on the Java drives. Just wanted to kind of talk through the basic assembly. Both the drives are virtually identical, the front and back. There's a very slight difference in that how they're actually mounted. So the rear drives, what you actually got is you've got two 6mm holes here and here, and there's a 6mm bar that goes right across because the rear Java drives are fixed on that bar, and the front ones are actually on. In fact, I might be able to just show you the front drive. I can get yeah. So the front drives are a little bit different because the front drives are actually turn that on. No, that's this steer frame. Yeah. So the front drives. There we go. The difference with the front drives is rather than the bars coming out, they've got these little U-shaped bars that actually provide the support, and the reason for that is that they're pivoted on top so that you can actually steer it. But other than that, the basic assembly is the same. So if you assembled any one of these, you'll be able to assemble the other three. We'll start with the rear ones. They're made up of a few parts. The frame. So what I tend to do is print the frame up first. So you've got the Java frame. This is C, A. So you've got A, B, C, and D. So if I'll just take some parts off so you can kind of see how they go together. So there's four flat parts. These are printed obviously flat down. You've got some holes there for bearings. These are 24mm bearings, so 24mm in diameter. I'll grab the actual bearings out shortly so that we can I can tell you which ones those are. And effectively what they do is they'll fit together like this. Fairly straightforward, to be honest. And then in the middle there's a number of frames. So if I just what I'll do is I'll just hide them frames so you can see what you've got. Is you've got a center block, very simple block, 4 holes in. This just bolts there and there and there and there. When you first put it together it seems a bit flimsy, but believe me, there's a lot more parts that go on. You've got these 2 end blocks here, they bolt in place. Now notice under the end blocks, once they're bolted in, there's a little hole here. That's for a screw. It self-taps into there and it digs into the metal bar that we've got in there. So that's effectively what locks the drives in place with an M3 bolt. If I just do a rough measure on that, that's 10mm will probably get you through that to dig into that bar, to hold that bar quite solid on those two, and it does hold it solid. Then you've got this frame and this frame. They're slightly different. This one here, which is holds the motor, obviously goes at the end where you've got the big hole, because that's where the motor goes. So basically, put these frames together, bolt these parts on, and then you can bolt the 2 outer frames on, and you'll create this kind of overall build. Now you've also got these holes here. If you look on both sides of them, the holes are on both sides. These hold the 7mm by 3mm by 7mm 7 by 3 by 3 bearing holes. So it's 7mm diameter, 3mm hole, and 3mm depth bearings. You've got 2 bearings, one pops on that side, one pops on that side. So you need 8 of those bearings for each corner. And actually, when you start to add all the wheels, you'll need a lot of those bearings. Now these are sealed up. The reason for that is it's all down to the bridging, so that we don't have to have any supports. But once you can do this at any point, like now, or you can do it as you take it off the machine. Grab a 4mm drill and literally just drill this out. Doesn't matter if you make it doesn't have to be perfectly central. Just all you want to do is so you've got a bit of a lip all the way around, because the bearings will make sure that that's center. But make sure that you drill this out and just clean it up a little bit. So I've left it there. That hole is nowhere near 4mm. What is it? It's yeah, it's 2.8. That's about 3mm in diameter. So if you get a 4mm hole, just drill it through there on all 4 of those corners before you start. It just lets those front wheels spin a little bit clearer. If you haven't done that, yeah, don't worry about it too much. It'll all still function and work. It's just that really you do want to sort of drill those out. Once you've assembled those, then there's 2 outer frames which bolt on the side, and they hold the main set of wheels. So we'll go through the wheels in a sec, but in theory you can probably assemble all of that together. Now on one side you've got these, on the other side you've got some extrusions that come out. The extrusions come out opposite side to where the motor comes out, and the reason for that is that holds then the front fascia or front plate. So all these are bolted together with M3 bolts. This, for example, is 17 mil. So I'll put some recommendations when I write. You've got 10mm thickness here, so 15mm M3s will do it. But again, if you've got a collection of them, you can just measure them against the side up until the point when I publish all the instructions. But they're not. There's so many bolts in here. You've got plenty of options on size, so you're not. It's not absolute necessity that you need 15 mil, whatever. You get away with 12 mils or 15 mils or 17 mils or whatever you've kind of got. And if they extrude slightly on the inside, it's not too much of an issue. Once you've built the main frame or the main plate, what you can do is you can pop these bearings in here, 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 and here. So 4 bearings at the side. But the next thing to probably add is probably some of the electronics, well, some of the hardware. So what we've got is there's 2 things. There's the polar loom motor, which these are the 37D motors. I used I think I used a 19:1 ratio ones on this, and then there's a polar loom coupler, which is this little thing that holds the gear. So I'll just move that to probably where it should go, so that coupler just drops onto there like that. And it obviously doesn't push that far in, so you can actually just move it out a little bit like that. Yeah, so it kind of sits in around about like that, and that holds the main drive gear. So you can pop the motor in. Don't pop the coupler in just yet. You've then got the remaining piece. So the reason we don't pop the coupler in is this gear. So the way this assembly works is you grab the coupler, you put in, I think it's M3 8s will probably do, M3 8mm. I'll just do a quick inspection to give you a bit more of a gap on what's that one. Yeah, it's 7.3. So M3 8mm bolts. Pop that in. 4 of them in, tighten them up, that will attach the gear to the coupler, and then the coupler, you've got a couple of grub screws which you'll see when you've got the coupler that hold it on. I'd highly recommend you use Loctite on the grub screws, because however tight you tighten these up, they will loosen up. I've got to say with Loctite, keep it away from printed plastic. It dissolves it, it makes it brittle. If you get blue, you get any coloured Loctite on these gears, they'll just dissolve, they just crumble. So toothpicks or small bits of Loctite to keep Loctite on. Once you've got that gear on, you've got your frame on, you can actually put this whole thing into the frame. Then before you actually put the coupler on, you've got a number of bolts that go round here that actually attach this motor onto the frame. Tighten those up, and once that's in place, then you can actually add the coupler and the drive gear. So you should end up with that, and then this gives you this side here where you can solder a couple of wires on here, and that's your drive motor done. So once you've completed that, we can then move on to the gear assembly. Now with these 2 bearings in place, your gear assembly is made up of these 6 gears here. Oops. I just not that 6 gears. So your gear assembly is made up of these 5 gears here, so apologies. So you've got the A gear, you've got this little plate here, you've got the middle, you've got this little plate, you've got this gear on the outside, so it's kind of like a sandwich. Now be aware that these little plates in the middle can theoretically go both ways. You want no gap between this outer plate and the little star drive in the middle. If you reverse them, there's a little spacer which you can probably see just about there. If you reverse them, that'll rub against that side plate. So you want that little shoulder there to go against the bearing. These are held in with two 35mm M335 bolts, which kind of go through there. So minus 35. I'll just show you kind of where 35mm goes through. So yeah, so your bolts will bolt right the way through into about there. So you can get away with 35. You might get away with a little bit further, but I tended to use 35s. Two 35s either side, and they go right the way through to that middle bit. So it gives a really good solid piece. And obviously then this gear meshes with this gear. So all you want to do then is just check alignment. If you need to adjust it, you've got access to the grub screws in this little gap at the bottom here. But you really want that in place, and you want that spinning quite freely. Once you've built that one up, you do exactly the same at the rear. So I'll just turn the rear on. So there's another one of those, but this one is freewheeling. It's just free spinning. So you do the same assembly there. And to be fair, the actual assembly is quite simple. Once you've got those two in, you've got the drive going. The next thing that we tend to put in is the little idler wheels. So I'll show you these again. So these are the wheels. You'll need 16 of these, a lot of these in, and these take the 7mm by 3mm by 3mm bearings in there. So 3mm hole, 7m diameter, 3mm deep, and what you've got one bearing on one side and another bearing pushes just on the other side into there. So each of the wheels have two bearings. So you can imagine that's 16 wheels. That's 32 bearings. Plus the 8 you've got at the front, you're up to 40 bearings already. So there's quite a lot of bearings on this. Same as these little things here. There's a hole in the middle that you can just use a drill just to drill out with a 4mm drill, just to clear that out. And then what happens is you pop these on, and these will actually then mount onto this plate with about a M320, so a 20mm M3 bolt goes through that bearings and holds it on there. What I tend to do is tighten it up just to the point when I can feel it, a bit of resistance, like I'm tightening it up, and then just backing it off a little bit so it spins freely. Once you've fitted one of those on there, you can literally just go around then and fit all the other ones. So there's a lot of these, so you just pop all these on all the way around. So once you've got these on, the last thing to do then is to put these idle wheels on, which are on the corners. So if I just show you those, you'll see these are tiny ones. You need 4 of each. And if again, just watch out for the bevels. So the bevels on these wheels here go on the outside, and the bevels on these wheels here go on the inside. You'll see some of these that haven't got holes in. Don't worry about those. Those are just spacers on my card. They're all like the identical same part. Same with these. I haven't got holes in. These are me just getting some spaces when I first started to do the CAD. So these are really simple. The bearings are actually already in there. You should have put one bearing on either side into the frame. So all you're really then doing is taking an M3 bolt, which 20mm or 18mm actually will probably do it. An 18mm M3 bolt goes through there, through the two bearings out the other side. There's some little shoulder spaces either side, similar sort of thing. Tighten it up, back it off, make sure it's loose. Then all you do is repeat that on each of these 4 corners, and that's pretty much your drive system built. Now once your drive system's built, your next thing obviously is tracks. The tracks are quite they do take a while to print, and there's a lot of them. There's nothing I can do about that because the Sandcrawler is a massive tractor vehicle, so you've literally just got to print all these things out. The assembly of the tracks, now I'm just going to see if I can get a good view on this by... It's the advantage of showing you CAD stuff rather than real plastic stuff is I can kind of start to hide stuff and animate stuff and all the rest of it. So if I just grab some tracks, let me just see if I can grab some ones to kind of show you. Select privacy bodies. Okay, so 1, 2, 3. I'm just going to move these out of the way just so I can show you exactly how the tracks assemble. So this is one track. Okay, the track assembly is actually quite well, I say it's quite easy. They take a long time to print, and each track it consists of 3 parts. So what you've got is you've got this middle piece here, which is the track. This is printed in flex, and you'll see it's got a little dovetail in flex. The reason I've done that is to minimise the amount of flex that we use, and also to reduce the wear. Flex is brilliant. It doesn't really wear at all. The weight of the Sandcrawler is not enough to create wear, so it works. And once you've put that on, what you do is you've got 2 of these. There is a left and a right, and literally these just push on, and then they push on the other side. You'll see that one side's got a little dovetail, the other side's got a flat piece. Obviously they dovetails and they just push together. When you push them together, there will be a very slight gap in the middle. It's intentional. It's really just to make a tight assembly. It should only be a little gap. If it's a big gap, just check the ends. Oops, what have I done there? There we go. Yeah, if it's a big gap, check these ends here where this overlap, where this bridging's here, just to make sure there's no bits of plastic that's stopping that from moving. So once those are together, you pop a M3 20 screw on there. So let's just measure that. So that's exactly 20mm. So an M3 20mm will move across there. M3 18s, it doesn't matter, either or will hold them together, and that's you've made one track. Once you've made one track, you then make more tracks. So you've got 30 tracks, I think it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Yep, so there's 30 tracks all the way around. It says it on the print anyway. So 30 tracks all the way around, and then what you do is you'll see on the tracks there's little holes. And you drop a 100mm by 2mm rods through there. If you can't get them in, if they're a bit tight or whatever, what I tend to do is put the rods in just in the very tip of a drill, and then just gently use the drill just to spin it into there so it fits quite comfortably. Repeat all the way through until you've got a full flat tread, and then what you can do then is attach the treads. You wrap the treads around the main drive, and then put the last piece in. Now, a little bit of a gotcha on this is make sure that when you are attaching the treads, okay, that you've already put in your 6mm rods that hold these together, and you've tightened this screw up here to hold them, because you haven't got access to these screws once you put the treads in. So the assembly is you build this first of all, you put the rods in, you get this into its fixed position, and then you put the last thing you do really is put the tracks on. I tend to leave the last rod sticking out a little bit, just in case that I want to sort of go back and revisit that whole. You know, I need to make some adjustments, or I've not got access to something. I don't tend to do that, and then literally it's just a matter of repeating the same for the others. The front drive's exactly the same assembly. The only difference is there's some extra, slightly different in how it prints. So this one, the front assembly, the frames are a little bit different. As you can see, they've got kind of some inbuilt parts here into the print, and then they've got these little shaped pieces that hold it together. But effectively, once you've understood how one assembles, these other ones assemble. On the fronts, what you've also got is you've got some captive, again the same bearings, 7mm by 3mm by 3mm bearings that go there, and there. The reason, and then you put a bolt through to hold them. The reason that they are is that these sit on a flat plate, so what they do is they take some of the weight, so that all the weight's not just on that single bearing. And there's another one here which is a 3mm bearing, and then you can take a self-tapping M3 bolt. There's 20mm there, but 18mm or whatever you want, and literally it's just a push fit, so that just slots into there. And all those bearings do is they take the weight of the main frame in addition to this bearing here, just so that we take some of the weight off. Same bearing that we've got, which is this 24mm diameter bearing. I'll make sure we pull we get the right bearings out. I think they're 15mm ones, but yeah. So you've got, I'll drop them on the instructions in the notes on the YouTube, just the bearings that's needed. But there's only two types of bearings: there's the big ones and the small ones, and you need quite a lot of both, really. And then these bolt into here with 3 bolts on the bottom, which hold those 3 frames, and these frames are bolted together like that. So you've got a bit more assembly on those frames, but again, it's all fairly sort of common sense. And that's pretty much your drive system then, and obviously then the drive system kind of fits into that whole piece on the rear. I'll quickly just show you the under assembly then, so you can get a bit of a picture. I still just working on this end piece here, so this front bit, the reason I haven't completed these 2 edge tiles, I'm going to use them to hold the front opening mechanism, so it took a little bit longer because I have another project to do, so but don't worry, it will be done very shortly. Then you've got, again, similar things on this frame. There's a couple of them bearing holes there and there, and then you've got a bolt that goes through it that holds onto these steering mech. It's basically rack steering, so you've got those go onto this rack. I'm not going to go through full steering assembly, I'll just kind of show you basically how it assembles. You've got a rack, you've got 2 parts of a frame, you've got the servo, and the servo turns this gear. I've moved away from gluing that in. I've actually used bolts to bolt that in because it's a bit more of a solid grip, particularly on these 25 kilo servos. Are quite chunky little motors. I've also, there's a hole drilled in there which allows you to put the cables, just make sure the cables stay clear when it actually starts to steer. And then you've got a similar thing at the rear. The rear sits on this fixed frame, but you've got these 2 little holes either side, which is for cable, so that brings it through the cable on this side on the front. And that's pretty safe. So I just wanted to get a video out there just so that I know there's a few people assembling these. It just gives you a few gotchas and a little bit of an overview of the assembly of the driver. It doesn't replace the instructions along with parts. I will put them together. I'm dreading doing the instruction on this because it's going to be like that. You need 3,703 bolts just to do all the body together, so hence I'm taking my time a little bit with those, but I want to get that, just want to get that front door, the opening front door modelled, and then we can get the main model part finished, which hopefully shouldn't be too long once I've completed the other project that I'm working on, which is the Edison, which is the big Tito that I'm sure you've seen videos of. So hopefully that was useful. If you've got any questions, just ping me on the interim while the instructions are out. Happy to kind of talk through any specifics if you get stuck on anything, but that should cover most of the drives.